Azar and Carl play a game of tic-tac-toe. Azar places an X in one of the boxes in a 3x3 array of boxes, and then Carl places an O in one of the remaining boxes. After that, Azar places an X in one of the remaining boxes, and so on until all 9 boxes are filled, or one of the players has 3 of their symbols in a row, horizontal, vertical, or diagonal, whichever comes first, in which case that player wins the game. Suppose the players make their moves at random rather than trying to follow a rational strategy, and that Carl wins the game when he places his third O. How many ways can the board look after the game is over? Okay, so this question might look a bit scary at first, but what you have to realize is we're not asking how many sequences of moves they can play. We just care about the final board, how it looks after the game is over. You see, how many ways can the board look? It's not how many ways can Azar and Carl place their symbols in order. We just care about the final position, not how we got there. So if Azar were to play something like this, and Carl were to win 3 in a row, that'd be the same. It would be considered identical as if Azar and Carl played like this. See the same ending position, even though the sequence of moves is different. So this actually makes the problem a lot easier to solve once you realize that we only care about the final position. So now we have to think about what it would look like for Carl to win in 3 moves. It would mean he'd place 3 O's in a row, and Azar wouldn't have 3 O's in a row. So what can we do here? We have 2 cases, as to how Carl can win. Carl can either win by putting 3 in a row diagonally, or he can win without putting his diagonally. So vertical or horizontal. Vertical or horizontal. And each case we have to consider separately. So case 1, Carl wins diagonally. And you can notice that Carl winning O is essentially identical to Carl winning here, like this, because they're mirror images of each other. So we only have to count the number of ways he can win like this and then multiply it by 2 for the other diagonal. So we can see that there are 2 diagonals times the number of ways Carl can hog one of the diagonals, and Azar places 3 X's in a row. And notice that the X's cannot be 3 in a row. Otherwise, Azar would have won before Carl did. But that's oddly convenient, because no matter how Azar places his X's now, they will never be in a 3 in a row. So we don't have to worry about Azar getting 3 in a row before Carl did. There are 6 remaining squares left for Azar, and 3 of them have X's in them. So you're multiplying 2 by 6, choose 3, which is equal to 2 times 20. 6 choose 3 is 6 factorial over 3 factorial, 3 factorial. You can check that this is indeed equal to 20. So there are 40 ways for Carl to win by placing his O's on a diagonal. Now, case 2 is if Carl's O's are vertically or horizontally. And it turns out that each of these 6 ways Carl can win vertically, horizontally, that's this one, this one, this one, that one, that one, and that one. They all have the same number of possibilities for final boards. So what we only need to do is we need to count 6 vertical, horizontal, and multiply that by the number of ways Azar can place his X's. For example, let's assume that Carl's O's are here, and you can verify that this is indeed the same counting as if his O's were in these 3, or in these 3, or even in these 3. So there are 6 ways for Carl to claim a vertical or horizontal stretch of 3 squares in a row. And after that, there are 6 squares left for Azar to place his 3 axes, or for Azar to have his 3 axes in. And you might be tempted to just say this is 6 choose 3 again, because it's not, because Carl could not have put his X's, for example, like this. Because since Azar, starts before Carl does, if Azar had placed his 3 X's like this, Carl would not have won the game, because Azar would have won. So you actually have to multiply 6 by the 6 choose 3 minus the ones that we're overcounting, because Azar can't have his x's in these three squares and he can't have them in these three squares as well. So that's two bad cases you have to subtract out. So the number of ways that Carl can win if he wins with a vertical or horizontal row is 6 times 20 minus 2, which is 6 times 18, which is 108. And finally, our answer for how many ways the board can look after Carl wins in three moves is 40 plus 108, which is 148. So our answer is D. Thanks for watching, and I'll see you next time.